Hi, I am Rosanel Ginha from IT2103. So welcome to my channel. So from this video, which is the chapter 6, which is we have to do some tutorials for this chapter, which is the chapter 6. So we have to tackle about the network layer, and then the network layer protocols. So in this chapter, we have to apply the knowledges that we have that we already understand in the Cisco and the and reading from the NetAcad. We have to answer all the activities from this chapter. So I think we have to start now. So first, from the first activity from the chapter 1, which is IP characteristics. So I will explain what is connection less best effort and media independence. So from the connectionless or IP connectionless. IP is a connectionless, meaning that no dedicated end-to-end connection is created before data is sent, as shown in the figure. Connectionless communication is conceptually similar to sending a letter to someone without notifying the recipient in advance. And the second one is the IP best effort delivery. So the figure illustrates the unreliable or best effort delivery characteristics of the IP protocol. The IP protocol does not guarantee that all packets that are delivered are in fact received. And the next one is the media independent. It operates independently of the media that carry the data lower layers of the protocol stack. As shown, the IP packets can be communicated as electronic signals over copper cable, as optical signals over fiber, or wirelessly as radio signals. So let's answer this. So from this IP characteristics, so fiber optics, cable, satellites, and wireless can all be used to route the same packet. So this belongs to this line. The next one is will send a packet even if the destination host is not able to receive it. From the connectionless. The second one is does not guarantee that the packet will be delivered fully without errors. From the best effort. No contract is made with destination host before sending a packet. From the connectionless. And the last one is packet delivery is not guaranteed. From the best effort. So and the last one is will adjust the size of the packet sent depending on what type of network access will be used. From the media independent. So that's it for this activity, and let's go to the next. So the next activity is IPv4 for header fields. So the first one identifies the IP address of the sending. This is source IP address. The next one is identify the upper layer protocol to be used next. So this is from the protocol. And from this identifies the priority of each packets for differentiated service. Identifies the IP address of the recipient host from the destination IP address, commonly referred to as hop count, time to live. And the last one is always set to 0100 for IPv4, this is the version. So this is for this activity. Let's go from the next one. So the next activity is the header fields, which is from the IPv6 header fields. We have version, traffic class, flow label, payload length, next header, and hop limit. So I will explain it to you one by one. So first, version. Version is field contains a 4-bit binary value of set to 0110 that identifies this is an IP version 6 packet. From the traffic class, which is this 8-bit field is equivalent to the IPv4 differentiated service or DS field. The third one is the flow label that has 20-bit field suggests that all packets with the same flow level receive the same type of handling by routers. The fourth one is the payload length, which is this have a 16-bit field indicates the length of the data portion or payload of the IPv6 packet. The next one is the next header, which is this have 8-bit field is equivalent to the IPv4 protocol field. It indicates the data payload type that the packet is carrying and enabling the network layer to pass the data to the appropriate upper layer protocol. The last one is the hop limit, which is hop limit have a 8-bit field replaces the IPv4 TTL field. This value is decremented by a value of 1 by each router that forwards the packet. When the counter reaches 0, the packet is discarded and an ICMPv6 time exceeded message is forwarded to the sending host, indicating the packet did not reach its destination because the hop limit was exceeded. So let's start to answer this activity. So from the IP header description, to suggest that all packets receive the same type of handling by IPv6 routers, so this is for the flow label. And when this value reaches 0, the sender is notified that the packet was not delivered from the hop limit. And the IPv6 header description identifies the size of the data portion of the packet from the payload length. Is always set to 0110. This is the version. Identifies the application type to the upper layer protocol, which is this is the next header. And the last one is the classifies packet for congestion control, which is the traffic class. So this is all for this activity. Let's start the next one. So from the next activity, which is identify elements of a router routing table entry. So a partial router routing table entry is shown. So from each section of the entry is identified by a circled letter above it. Select the correct routing table entry section for each output. So from the number 1, the elapsed time since the network was discovered. So this E. The administrative distance source and metric to reach the remote network, which is C. How the network was learned by the router. Shows the destination network which is B, or 192.168.1.0.224. The next hop IP address to reach the remote network. Letter D. And the outgoing interface on the router to reach the destination network, which is F. So let's check. So let's proceed to the other activity. So let's start the fifth activity, which is the description of router functions and hardware parts. So from the description, connects router to external network usually over a large distance, which is one interface. A way to remotely access the CLI across the network interface, which is the Telnet or SSH. It connects computers, switches, and routers for internal networking, which is LAN. A local port which uses USB or low-speed serial connection to manage network devices, which is console port. A port to manage router using telephone lines and modems, which is aux port. Let's check. So this is for this activity. Let's proceed to the next or the last activity. So from this activity, which is the router boot process, from the instruction, drag each of the steps on the left to appropriate field in the table on the right to show the router boot process order. So from the router boot process, from the router boot process, which is the step 1 is perform post or hardware check performed by built-in a ROM chip. From step 2 is the load boost strap or copied from ROM to RAM locates the IOS. From step 3, which is load the iOS operating system file for the routing loaded into RAM. After boot, strap finds the iOS file to be used. And the last step is the load the configuration file from flash and VRAM, a TFTP server, or go into setup mode to create a configuration file. So that's all for this chapter 6. Thank you for watching.